Alright, so we're going to practice writing inequalities from some kind of silly word problems. And this is a lot like writing equalities, also known as equations, from word problems, where you've got a variable, you've got an equal sign, and things on different sides of the equal sign. But for inequalities, it's all like that, except instead of an equal sign, it'll be some kind of non-equal sign, like less than, greater than or equal to, less than or equal to, something like that. So, same basic process, just something else instead of an equal sign when you write the equation. So, let's look at these examples, and we'll just go through and just kind of talk it out. I'll show you the process. So, a local dragon has demanded that I feed her. And by the way, I recommend reading the whole word problem to get a sense of the big picture, and then go through and pick out the key terms, the key ideas, the key numbers, etc. So, a local dragon has demanded that I feed her my world famous from scratch tomato soup by the end of the year, or she'll burn up my neighborhood. So, to make her enough soup, I'll need at least 100 tomatoes. I can't afford to buy that many tomatoes, so I'm going to grow them myself. My favorite cultivar or type of tomato produces about 15 tomatoes per plant. How many tomato plants should I plant? Okay, so what we need to figure out is the number of tomato plants to plant. And let's go green here. So that's gonna be our variable. So let's call that P. That's the number of tomato plants. Okay, so let's go through again. So local dragon has demanded that I feed her my world famous from scratch tomato soup by the end of the year, or she'll burn up my neighborhood. To make her enough soup, I'll need at least 100 tomatoes. So at least 100 tomatoes. So whatever I do, however many tomato plants I grow, the result needs to be greater than or equal to 100 tomatoes. Okay? I need at least 100 tomatoes. If I have 100, okay, I just squeak by. If I have 101, great. 110, great. Whatever I do, I can't have less than 100. So the number of tomatoes I get will need to be greater than or equal to 100. So that's what it means when I need at least 100 tomatoes. Okay, so now what are we trying to solve though? So I'm going to grow these tomatoes myself, and my favorite cultivar or type of tomato plant produces about 15 tomatoes per plant. So I'm going to grow a certain number of plants, and for every plant that I grow, I'm guessing that I'll get about 15 tomatoes. And it's, in real life, it's not going to be that precise. You might have a tomato plant that produces anything from 0 to 30 tomatoes, or you might get at least 3 or 4, or whatever. But let's pretend that we can pretty much rely on these tomato plants producing 15 tomatoes per plant. So I've got the number of plants here. That's just P. We don't know how many yet. And for every plant that I grow, I'm going to grow 15 tomatoes. So P times 15. So every plant I have, I'm going to have 15 tomatoes. So P times 15 will be the number of tomatoes that I get. The number of plants times 15 will be the number of tomatoes I get overall. And that number of tomatoes needs to be greater than or equal to 100, so I can make that soup for the dragon by the end of the year, so my neighborhood doesn't get burned up. Alright, so let's look at another one. Let's go through the process here. Let's read through. Alright. I would like to run more than 30 miles this week because my friend bet me I couldn't. If I rest for one day so that I give my body a chance to heal itself from all this intense running, how many miles per day do I need to run in order to prove my friend wrong? So what I need to solve for is the number of miles. So let's just call that M. Let's do that in a different color. Alright, I need to solve the number of miles. Okay, so I've got M, and what sign do I need? So I would like to run more than 30 miles. So however many miles I run for however many days, that needs to total up to be greater than 30. I would like to run more than 30. So 30 won't be enough, 29 won't be enough, 28 won't be enough. It needs to be 31, 32, 33, 40, 80, something. Anything more than 30. So, okay. Now, we need some more information here. Because the question is, how many miles per day? Per. That's good. Keyword there, per day. So how many days am I running? Okay, so I would like to run more than 30 miles this week. A week is 7 days. If I rest for 1 day, so I'm not going to run one of those days. So I'm going to run for 6 days. So I'm going to run 6 days, and I'm going to run a certain number of miles per day. So 6 times the number of miles per day, so 6 days times the number of miles per day needs to be greater than 30. So that's how I'd set that up. Last one, number 3, and I'll write the stuff down. Well, actually, yeah, I'll write down. Okay, so on a planet called Birth, a swarm of alien life forms went crazy yesterday and blew up more than half of the planet's forests. Today there are about 30 million square kilometers of forest left on Birth. How much forest did there used to be? So actually, I'm going to draw a little picture first to help me visualize this. This is a little complicated. This is, if you get this one, 10,000 bonus points to you. Don't spend them all in one place. Alright. I'm going to draw a little thing here that symbolizes the total amount of forest that there used to be. Okay, if they went crazy yesterday and blew up more than half. Okay, let's pretend this is the halfway mark. Here's half of the forest, here's half of the forest. If they blew up more than half of the forest, let's say they blew up this much, so it's gone. What do we have left? What's left is less than half, right? If they blew up, if more than half is gone, what's left is less than half. So today there are 30 million square kilometers left. So we're looking at the part that's less than half of the total. So there are 30 million square kilometers of forest left. And I'm just, alright, so I'm just going to write that as 30. We need a new color here. Write that as 30. And then we can just remember that this is in units of million square kilometers. That's fine. So once you solve it, in fact, I'll solve it for you and then show you what to do with that. So to avoid having to write all those zeros, I'm just going to write 30. So this is what's left. And so what's left is less than half of the amount of forest that there used to be. So half of. So F, if we use F to symbolize the amount of forest that there used to be, 1/2 times F is half of the amount of forest, and what's left is less than half of that. So that's our setup. So what we can do, so I'll just solve this just to show you that this is actually good for something. So I need to isolate F, and F is being multiplied by 1/2, so to undo that, so to speak, I'm going to multiply it by 2/1. See, 1/2 times 2/1 is just 1. See, the 2's cancel out. Here, I'll just 1/2 times 2/1 equals 1 times 2 is 2, 2 times 1 is 2, 2 divided 2 is 1. So if I do that, all I'll have left is 1 times F, which is just F, so then F will be isolated. So I'm going to multiply it by 2/1. You can do that. When it's a fraction, you just flip it over and multiply. So I'm going to multiply this out of the inequality by 2/1, and so that means I have to do the same thing over here, times 2/1, which is just 2. So 30 times 2 is 60. So 60 is less than the amount of forest. So the way we interpret this is that we knew that this is in units of million square kilometers. So 60 million square kilometers is less than the amount of forest that there used to be. Or we can flip this around. Say F Let's flip this completely around, mirror image. F is so the amount of force that there used to be is greater than 60 million kilometers. We don't know the exact number, but we know it's greater than 60 million square kilometers.